So this is a video of engineering metrology, that is in the production part of mechanical engineering for GATE. So basically the things that I really want to emphasize on these gauges, they are very important and they are really difficult in some part to understand. So I really think of making a video and letting you understand that how things have been playing out, and it will be difficult, not difficult for you. So let's get started, and I would like to start off with the thing that is what is called material limit. What is maximum material limit? What is material? So suppose it's a hole, so it's a hole. So now this is type of hole. So this is the limit, this is the limit. If we just decrease the thickness, then the limit is increasing, the hole size, this is increasing, no? So that is, we can see there. So it is upper limit, the maximum amount of material that can hold. This is the upper limit material that can hold. Now if we just remove it, this is the, so this is the lower limit, this is the maximum dimension. And now for shaft, what you can see, this is the lower limit, so small, it's a lower limit, and if you can 0.5 we are adding, it's a maximum material limit. So maximum material limit value is higher, here minimum material limit is lower. But for hole, what happens, maximum material limit happens at lower end. This is the maximum material limit, lower end, no? In minimum material limit and upper end. So it's a very tricky question, just keep your mind cool. And then, so first thing that first, that is, what are the go gauges? What does that, go gauges are those gauges which can enter in the maximum material limit. So that's why we are taking the maximum dimension, we are checking, not the smaller. So maximum dimension for these two things. So for shaft, sorry, go gauges is, that is the, so for shaft, that is the maximum material limit. It is, you can know, this is the, so first thing I might said wrong, but this thing you can understand, this is the whole upper side generally, and this is the shaft. So what I have said, in the material limit, maximum material limit, when a gauge can enter, that is the go gauge. In the maximum material limit, when a gauge can enter, that is the go gauge. And no go gauge is that when in the minimum material limit, the gauge can't enter. So in a shaft, it's a shaft, it's a maximum material limit, here it can enter. So obviously in the smaller one it can also enter, no? This is the shaft. So let's say in the, this is the maximum material limit for the shaft is shown below, and this is the maximum material limit, so let's say it can enter. Obviously this is the go gauge. And for the hole, maximum material limit is this. So if the hole can enter here, no? If the gauge can enter here, suppose we are putting some enter, so it can obviously enter here. So that's why we are taking at maximum enter. No, let's say for the hole, what is lower, so minimum material limit. So this is the minimum material limit. So no go gauge one, here if we don't enter, if it cannot enter here, obviously here it will not enter. So that's why it's a no go gauge, obviously checked, and minimum material limit. For shaft, you can see, if here the shaft cannot enter, so will it be able to enter in this side? This is the bigger dimension. No, if it here not enter, there it is obviously not going to enter. So that's why how you are checking the gauge and how the values are coming. This is the main part that I need you to understand. No problem on rejecting the accepted component, but it should not accept the signed in single rejectable component. So go gauge are at maximum material limit, and no go gauge are in minimum material limit. These two things I have said. So this is the no go gauge in minimum material limit. So go gauges is at maximum material limit, and no go gauges are in minimum material limit. So it's a go gauge, so it's a maximum material limit, it's a maximum material limit, that is the value. It's a no go ring gauge, it is the minimum material limit that we are getting. Necessary evil, all the gauges are provided with tolerance, so it's not simple. So now this is the values we have been given. Now this can see, so go gauges are in maximum material limit. For shaft, it is the maximum material limit. For shaft, the lower limit is maximum material limit, and for hole it is the bigger amount, that is the maximum material limit. For every time there is a gauge tolerance, there is a gauge design, there is a represent taking go and no gauge, and there is a weight tolerance that we are giving. Without weight this is the length, without weight this is the length. So go flag gauge without any weight, that is the 30, basic size 0.05. So this is the tolerance given. So that's why from here we are in 0.000 and 0.05. And no go gauge for the for the whole, that is the minimum lower limit, minimum material limit. So this is the minimum material limit, that is 0.5, and this value, that is 0.45. because total is 5 and this minus. And for here, that is the there is a tolerance, and there is a word tolerance always given in the go side. Always in the go side there is a tolerance, never in the no go side you have been seeing any type of tolerance levels. This is the very much important point that you need to keep in mind. Okay, so 30 for the go edge, 40 for the limit would be 0.05 because it's the tolerance, and above limit is 0.05 plus this one. And for the same cases also, now some material can be wasted, so that's why we have been giving the wet tolerance gone. Then some more material we need to save, so that's why we need to go beyond the our limit, beyond what I have been said. Then we have to go outside our basic size, and it's there is a international inspection gauge tolerance. There we are just little liberate about the things, about the values, that how we are taking, and about little bit about the tolerance level we are little allowable, because we can take a little extra or little later. So that's why above you can see there is a minimum material limit, minimum material less than that also sometime we can take, and here also for the maximum material limit some amount of bigger than that, that can also be taken, there is no problem. But in case of only inspection gauges, that is possible. In other cases this is a very difficult thing, and this is a very out of the rule that we have been given. So that's why it's simple that you need to remember. So x by 10 is a tolerance that is being given to here above the limit. Now gauge tolerance always outward, that I have been saying, and rejected component can also be recovered by this one. That's why we are giving. So it's a in a generally work purpose for any inspection. There is a precision that is been needed. That type of things we can't use these things because there is a difficulty that we can face in the precision. So we need a very tight tolerances. But here we can give some amount of tolerance because it's a workshop. There's a some amount of play that can be adjustable. That's given. So how much? There's a ISO gauge. So there is some rule, there is a tolerance is greater than 0.01, and then there is a 0.001 that has been limit. So always in the go side that is been given, everything is same, violation of the rules. So now this thing, so it's a go ring gauge. Go ring gauge is a go ring gauge. So you can see how is a go ring gauge is given. So in the maximum material limit, if it entering in the minimum material limit also it can enter na? So that's why now coaches, this you have to remember, this you have to remember. Okay, from this tolerance topic has been ended here. I hope you have understood these things.